Hey, Bogdan Brzeski here. Welcome to another video on quadratic functions, word applications, interesting questions involving sports. So let's dive in. So we know from other videos that algebraic interceptions of quadratic functions may have three possible solutions, but in this word problems, we're actually going to see if mathematical answer does make sense in this reality where certain constraints are provided. So we know all of this that you see on the screen where you put together, this is the tool, this is the pattern that you're going to have to use, put the quadratic equation of a line together, create a new equation, and then solve it. But now you have to make the proper finding based on the question provided. So, example. This is a soccer game example in North America. Everywhere else we call it football. It's a beautiful game. If you don't know, probably you do, but let's walk through this particular example. So, during the game, the ball follows a parabolic path. So, when the ball is kicked, it follows the parabolic path given by this quadratic equation. Y is equal to negative 0.25x squared plus 2x. And then when the ball flies up in the air, a teammate runs towards the path of the ball, jumps up in the air in this line where you have the equation y is equal to 0.5x plus 1. So the question is, find the points where the ball and the player's heads are the same height. So where do they meet? So the player would take the ball and hit or redirect it with his head. Part B, determine whether the player can make the contact. So the anticipation is that usually the range of the height of jumping is between 2 and 2.5 meters. So to give you things, to put things in perspective, if you measure height in feet, I'm 6'1", so 2 meters is about less than 10 inches above my height. So obviously that is a attainable goal. 2.5 meters, so this is another about 3 feet, give or take. That's a high jump for some players. So realistically, we would assume that that will be the expected height. So that will make sense in the moment when we start solving. And then we have to interpret the findings and assign a proper solution that is aligned with this word problem. So let's go. When the question defines the situation, it is a good idea, strongly recommended, to create a diagram. You create a diagram of your own, using your own skills. So this is my sort of picture of the situation. So the ball on this diagram is represented by this parabolic shape. So the ball flies up in the air and then comes down. And there is 2 points of intersection with the line, because the line given by the formula, slope form y-intercept, implicates that there are 2 points of intersection. So mathematically, this is nice and dandy. We know we can find the solution by putting the system together. And then there will be 2 heights. Maybe this height is too low, so that will be dismissed point of intersection. If this height goes above the range, because remember, they give us the range between 2.5 to 2 meters. If this point is too high, realistically, mathematically it would exist, then we have to make the adjustment by moving the location of the player so that it will fit in that interval. And this is what we will show you how to do it. So at the end of this video, we'll be a master chef, if you will, when it comes to solving quadratic equation with word problems application. So step 1, traditionally, you know what's going on. You have equation of a parabola, equation of a line, put it together. You must do that all the time and then interpret the solution. So move things around by shifting everything to one side and arrange them in descending order so that the second degree term, then the first degree, and the constant values. When you put those numbers and terms together, you simplify into that. Now, this quadratic equation has decimals. You can work with decimals, that's fine, but I suggest that you always make it easier for yourself. Instead of working with decimal coefficients, which are messy when it comes to solving it by using quadratic formula, why don't you make it into whole numbers? So in this case, by multiplying the entire equation by 4, actually by -4 to eliminate negative signs, because again, very practical skill for you, I'm going to share, is to attain questions with lowest possible numbers, with whole numbers instead of fractions or decimals, with the least possible amount of negative signs. So by -4, you get 1, times -4, you get 6, and times -4, you get 4. There you go. Boom. All right, so on this slide, you will see that A is now 1, nice. B is -6, beautiful. C is 4, amazing. So put it together into the formula -b. So remember, -6 is +6 here in this formula. Inside of the formula, -b², common mistake. -b, put in brackets and show it to the power of 2. You avoid big mistakes by doing that. -4 times A times C. Amazing. And now we have a square root 20 as our discriminant. It is positive, so we anticipate 2 solutions, right? Square root 20 is definitely greater than 0. So you cannot simplify 6 and 2 that most students would be tempted to do. If you want to show mathematical neat solution, you would have to change 20 into the product. 4 times 2, so 4 outside would be 2, and then you divide by 2, 6, this 2, and that previous 2, so that you get 3 plus or minus square root 5. But you're not going to leave this answer in that possible form. You want to show that number using decimals, because this is a word problem. So one point is at 5.24 and the other point is at 0.76, give or take. So when rounded, you have 0.8 meters away from the start of the ball flying up, or you have potentially 5.2 meters horizontal distance away from the ball flying up in the air. Now, let's find the height. So find out corresponding heights for each point. So when x is 0.8 meters, you do the math by substituting into the line equation. This is the easiest for you to grab. You can do the quadratics, but it's more work. So y is equal m times 0.8, m is 0.5, plus 1, and then you add it, 1.4. So this is 1.4 meters at that horizontal distance away. This is the vertical height, 1.4 meters. The second point at horizontal distance 5.2 meters away, plug it into the line equation, boom, you have 3.6. So the first height is 1.4, the second height is 3.6 meters. Does it really correspond with the reality of the situation? So the first height, 1.4 meters, so this is like a less than 5 feet, just about 4 feet. So you can appreciate it's a little bit too low. So there is very unlikely that this point of intersection would be reasonable answer. But the second intersection is too high, because then the usually jumper would not go up to that height jumping from the ground. So then we have to interpret the situation. Mathematically, we have those 2 points, but then we have to make sure that in reality, this is a solution that you would consider. So what happens? When you observe that the ball path intersects the line at 3.6 height, you would say that is way too high. The margin of possible height is between 2.5 and 2 meters. So anywhere there, you would anticipate the ball to be intercepted by the header. So it is past 5.2 horizontal line. So the player has to be waiting for the ball a little bit longer, be away further than 5.2 in order to get to that right position. So arbitrarily, you would select, for example, 2.3, 2.2, 2.4, 2.5. Any possibility would be good. So please do not get hung up on that. Where is 2.3 from? Any number from that interval between 2 and 2.5 is fine. Any. So pick that height, use the equation of that quadratic function, and solve for x. So rearrange this equation by putting everything to one side, you know the routine, and solve it by using quadratic formula. Solve that equation, and you will see that you will have two potential roots. One even could be negative, one is positive. But which one would you take? The one which is greater than 5.2. You don't consider the one that it's less than that, because we already knew that the first interception is unreasonable at 1.4. So you don't want to do that. And you will consider the distance which is greater than 5.2. So there you go. When you do that, you find two roots and you take the one that is reasonable, greater than 5.2, which is 6.6. So this would be the reasonable location of the player intercepting the ball. So this is the example that shows you mathematical modeling is one thing versus the reality. And when you're given the restrictions between 2 and 2.5 meters range, you would want to show the solutions based on that restrictions in addition to your mathematical solution that you did already for this word problem. So hopefully that makes sense. Hopefully now you have more clarity how to approach word problems, how to realistically provide solutions that are corresponding to the context of the word problem. So thanks for watching. Don't forget to do the practice questions that would simplify the way you think and makes you stronger in mathematics. Thanks. I'll see you again next video. Bye for now.